Hi, this is Ken Rosever, and we're going over how to graph rational functions. Um, I'm going to review some problems that we went over the other day, and I'm going to post them here one by one so that if you had trouble following with what we were doing last time, you'll have this little review. Okay, so here's one of the problems we were given. Anytime we're going to draw a comprehensive graph of a rational function, we should be looking to find the following things. The vertical asymptotes, I'll just put VAs. The horizontal asymptotes, we should be looking for the x-intercepts, the y-intercepts, any crossing points, and extra values as needed. So I'm going to walk through each of those. So vertical asymptotes first. How do we find a vertical asymptote? Well, we should begin by putting the problem into factored form. So we're looking for two factors of 2 times negative 3, a times c, negative 6 that add to 5. Two factors of negative 6 that add to 5 are positive 6 and negative 1. So I need to create a positive 6 and a negative 1. And there we go. So that is the factorization of the denominator. The vertical asymptotes, I said asymptotes, I apologize. The vertical asymptotes are found at unshared zeros of the denominator. We discussed in class that shared zeros create holes in the graph. I'm not going to get into that here because we don't see that, so we're not going to worry about that. We just have to find the zeros of these two guys. Neither of them are shared with the numerator. So what makes this equal 0? 1/2. What makes that equal 0? Negative 3. So those are the vertical asymptotes. Next, we're going to find the horizontal asymptotes. Horizontal asymptotes are determined by comparing the degrees of numerator versus denominator. And there's pretty much 3 cases. Either the degree of the denominator can be bigger, I call that case 1. The degree of the numerator and denominator could be equal, I call that case 2. And case 3 is when the degree of the numerator is larger than the degree of the denominator. In this case, we have case 1. The degree of the denominator is bigger. This is degree 2. This is degree 1. So since degree of denom is bigger than degree of num, y equals 0 is the HA. That's case 1. Anytime the bottom is bigger in degree, then the bottom grows quicker than the top for large values, and the ratio here will approach 0. So now we have the vertical asymptote, we have the horizontal asymptote. Now we're going to find the y-intercept. The y-intercept is an easy point to find. We set x equal to 0. Basically, we find f of 0 if it's in function notation. So I'm going to plug in 0. 0 here, 0 there, 0 there. When I plug in all those zeros, I'll have 0 plus 1 over 0 plus 0 minus 3. So I'll have 1 over negative 3. So the y-intercept is 0 when I let x equal to 0, comma, negative 1/3. Now, to find x-intercepts, pushing this up a little bit here, x-intercepts are found at, and I'm going to write unshared again, unshared zeros of the numerator. What do I mean by unshared? I mean if there's an x plus 1 on the top, there's not also a x plus 1 on the bottom. In that case, if we had an x plus 1 up here and an x plus 1 down there, those two things would kind of cancel each other out, and the effect would be that there would be no x-intercepts at all, and in fact there would be a hole in the graph at -1. That's not the case here. We have no shared zeros. Nothing that makes the bottom 0 also makes the top 0. So we're just worrying about what is the 0 of the top. The 0 of the top is -1. So that is the location of the x-intercept. It's at -1, 0. When you plug in -1 up here, it makes the numerator 0. It does not simultaneously make the denominator 0. So we're all good. Why do we worry about making the numerator and denominator 0 at the same time? Because 0 over 0 is undefined. So that's part of why there would be a hole there. Let me graph what I have here. So we found x-intercepts, vertical asymptotes. We found 2 of them. Horizontal asymptote, the graph approaches y equals 0. Y-intercept, and we have the 1 x-intercept that we got from the 0 of the numerator. So here we have the result. 1, 2, 3. 1, 2, 3. X equals 1/2. X equals -3. My horizontal asymptote is on the x-axis. These aren't super visible, so to highlight them a little better, I'll actually use a highlighter. So y equals 0, x equals -1/2. That doesn't really show up that well either. And x equals -3. Maybe if I just do a thick line. So there's the asymptotes. Alright, now I'm going to plot these 2 points. 0, -3 is approximately right there, and -1, 0 is right there. Because this is sloping down, it can't pass through the vertical asymptote, so it has nowhere to go. It's got to come down and this way. So there it goes. And if it goes out the bottom, it comes back in the top, it'll end up here. Then this is going this way. I know it doesn't turn around and come back down because the 0 of the numerator does not have a multiplicity of 2. That would turn it around. So it goes out the top, it comes back in the bottom, and that is a good sketch of the graph. So that's it for this one, and I will see you when next I do.